Hello students, a very warm welcome to Gravitation PYQs by JEE English, and today we are on the part 6 of the Gravitation PYQs. We have already completed our discussion on JEE Advanced problem, and we are about to complete a discussion on JEE Mains 2020 problems, and soon we will be also going to the rest of the model problems, different kind of model problems. If any similar, we will skip them, but we have many more problems coming in the upcoming session, so stay tuned. One of the most important topic, as you have seen, there were many questions just in JEE Mains 2020, and we'll be soon also seeing how many questions were asked in JEE Mains 2019. So a very important chapter, a very easy chapter so far. I don't think any question was really challenging. In terms of most of the questions weren't challenging in 2020. But there are many interesting problems coming up today. That is like the most interesting part of today's lecture. What are we going to do today? We are going to get started with some, problems around your Kepler's law. So these are some interesting problems that were asked in 2020 on your Kepler's law. Not only that, we are going to also understand something known as, if there are two planets, how do you launch, a satellite or your rocket such that it moves from one planet to another planet? In terms of your problems and what are the things and the complications involved in that. All right, basically we'll be solving JEE Mains 2020 problems now. Okay, then let's get into this session. Let's not wait anymore. And that being said, I'm Muralidharan Krishnan. I completed my MS in electrical engineering from one of the top ranking American university. I'm also an IIT who completed BTech from IIT Guwahati. I have 4+ years of experience preparing students for IIT JEE and other competitive exams, and I filed 25 patent applications on state-of-the-art technology in India, US and Canada. And that being said, if you're looking for a complete package for your JEE Mains and JEE Advanced preparation, it's going to be Unacademy subscription in India. Why do we say that? Because we have the best educators across the nation, and this includes legendary authors of your JEE preparation book like DC Pandey and DC Gupta sir, and you can attend daily live interactive classes with them on a very interactive platform with polls and leaderboards, where your learning becomes really interesting. Not only that, you will also get access to national level test series set by the best educators, and you'll be attending this quality paper and you'll be getting analysis post. And using this analysis, you can improve upon your overall performance. Yes, that is going to be one of the key parts of your JEE preparation. Not only that, one of the most important aspects of your JEE preparation is also covered in Unacademy subscription. So you'll also get access to lots and lots of live doubt clearing session. That too in a very structured manner, so that you do not have any doubts in the mind. And in fact, every course is going to be structured. You don't have to worry about the planning. We take care of the planning with doubt clearing session, quizzes and mega. So it's a complete package that is taking you in a systematic manner throughout this journey. It's a champion's tool for your JEE Mains and JEE Advanced preparation. And not only that, we provide unlimited access throughout the period, and there are no restrictions on the batches and etc. You can attend as many courses, you can enroll and attend to as many courses as you want. And how do you avail Unacademy subscription? You can do it either from the web-based version or the app-based version, right? And coming to this part, you may want to download the Unacademy learning app, because this gives you the sheer advantage of attending classes from anywhere. Do log in, click on the left hand top corner extension bar, select plus, and then select IIT JEE as your goal, and then hit on this get subscription button. And post this, you'll be redirected to the payment page, and if you're aware of it, well and good. If not, which program you should be going for. So let's say you are a 2021 aspirant with no plan for drop, then you may want to go for a 6-month subscription. Okay, that is like students who are going to give the exam now. And how much is that going to cost you? Near about 25,000. And let's say you are a 2021 aspirant but have a plan for drop, right? So planning to drop, this is for you. And also you can be 11th class students and who has completed significant part of your syllabus, like 50% of your syllabus. You may want to go for a 12-month subscription, which is going to cost you how much? Less than 35,000, 34,650. And let's say you are a 2023 aspirant and you are just starting out right now, so you will be going for, or you can be even 10th class, you will be going for a 24-month subscription, which is going to cost you only less than 70 rupees a day. That is 50,400 for 2 years, near about 25,000 per year. So this is about the plus subscription. We have something beyond plus subscription known as iconic subscription. On iconic subscription, you not only get access to the features of plus, But along with that, you'll be also getting, like access to one-on-one mentoring session and personal coaching from IIT and NIT alumni who are educators on our platform. So think about it, IIT and NIT alumni who have previously gone through the journey and successfully cracked the exam, they know the ups and downs, so they will be giving you the necessary guidance and motivational sessions to keep you, going throughout this journey in a more energetic manner and also in a very strategic manner. So they will be giving that expert guidelines and strategy sessions that are necessary for your preparation and for your exam. So yes, students, if you can afford it, this is going to be one of the best things for your JEE preparation. And how much is this going to cost you? A 6-month subscription is only going to cost you 34,200, and a 1-year subscription is going to cost you 58,500, and a 2-year subscription is going to cost you 90,000. For 2 years, that is going to be like 45,000 per year. So yes, students, and make sure whether you go for plus iconic 6 months, 12 months or 24-month subscription, you apply Murli live code so that you get maximum discount on your subscription purchase, right? And you would apply this and you will see this. If you don't see this pricing, definitely do apply this. And not only that, you can apply it on this combo subscription as well. What is this combo subscription? A combo subscription is something that we have recently introduced, where you can get your IIT JEE and CBSE board coaching at one place at an economical pricing with the best educators across the nation, that too in a very systematic and structured manner. So yes, it can go as low as less than 90 rupees a day for 2-year subscription, and less than 120 rupees a day for 1-year subscription. It is going to be one of the most economical packages, economical complete packages you must have ever come across for both your CBSE board and IIT JEE preparation. And we do also have different combinations of this combo subscription. So for an example, you're seeing a plus and plus over here, but we do also have an iconic and plus combinations, different, all the permutation combination that you can expect. So make sure, I'll come to that, what is the advantage of going each one of them, going through each one of these combinations, or what is the pricing, etc. at the end of the class. And make sure you apply Murli live code so that you get the best discount on your combo subscription as well. Okay, so let's get into the first problem of the day. So this is really a very good problem, because we might have not discussed this problem during even our concept and problem session. So the thing is, there is a satellite and it's an elliptical orbit, and it's moving around a planet P. Very easy question, actually. Literally, this could be the easiest question that would have been given in the paper. It is observed that the velocity of the satellite when it is farthest from the planet is 6 times less than that of when it is closest to that of the planet. Basically, they are saying, when it is far away, it is having, some velocity that is, 6 times lesser. So you can say it's 6 times more at the nearest point. So we are basically discussing about what kind of 2 points, aphelion and perihelion, right? Okay, the ratio of the distances between the planet and the satellite at closest and the farthest point of going. Of course, this is an easy one. We understood it. If the ratio is 6 to 1, it should be 1:6. Right? What are we dealing with? We are dealing with conservation of. But let's discuss this concept in detail. There's nothing much to discuss in this. But let's see what happens. We do have a situation here where your planet is somewhere at the farthest point, right? We generally say that A into 1 plus E, but you are not going to say this over here, because just let's see what is this thing. And where does this planet lie? This planet is on one focus, and there would be an empty focus. Okay, there would also be an empty focus, isn't it? Yes. So it's not kind of like a circular orbit where the speed is uniform throughout, but rather the distance is changing. But rest of the quantities are conserved as such. If you are carefully noticing this, rest of the quantities are conserved. Okay, let's call this as R1 and this as V1. Okay, and this is empty focus F2. And let's take the nearest point. There's another such one. And this as R2 and this as V2. Let's assume the planet is going in this direction. I mean, like this, it is moving in this direction. Planet is rotating on its own. It's also following its orbit. If you remember the kind of simulation we saw, that video that we saw, planet will also keep rotating. In fact, that happens even for the entire solar system, right? Sun keeps rotating and planets are following around it with that kind of elliptical orbit. Okay, that's none of our business in this question, but that's a very interesting video. That's why I'm reminding you that thing. It was really, you know, a concept that we wouldn't have known if not for this gravitation chapter, right? So anyway, let's get into this problem. It's a very simple problem as such. First of all, if it's moving in this direction, velocity is going to be like this over here, and velocity is going to be like this over here, right? It's in the tangential direction basically. So okay, first of all, let's understand. I'm just going to draw a vector. If it was at some other angle, how do you do it? This is an easier question though. Okay, what is the angle? 90 degrees. Similarly, in this case, what is going to be the angle? 90 degrees. Simply 1 is to z, but yeah. But if it was some other angle, some other distance is given to you, be very careful. Okay, you should be able to 90 degrees. R1, and so R1 is also a vector. You do not forget R1 is also a vector. And V1 is like this. Okay, the same V1 is written over here. Now I hope you have a better clarity. Okay, so that is it first of all, and everything is completed actually. Let's say that angular momentum at this point is L1 and L2. You know it that from conservation of angular momentum, right, angular momentum and what are all conserved in this cases. Let's say velocity for a certain point is given to you and you're supposed to find out the velocity at another point, or the radius of 2 points are given, velocity is given, then you're supposed to find out velocity, like radius or something. I think in that case it's very easy. Let's say only one parameter is given to you, like radii is given to you, or radius is given to you, and velocity of 1 point is given to you. Then you are supposed to find out, some ratio is given to you for r and v. Then which are the two principles that you will be using? Which is the two principles based on which you Kepler's second law was derived? One is from conservation of angular momentum. In this case, this itself is good enough. And the other one is the conservation of energy. Damn simple problem. Think about it. If you understood the basic concept, you could have scored just 4 marks within no time. Like the moment you have a look at this question. But basic concept is the most important thing. L1 is equal to L2. That's it. So what is the value of L2? Mass of the planet, will be taking certain mass of the planet. Let's keep it as m and m. Okay, that's not going to change anyway. M into V1 R1 sine theta 1, which is like sine 90. So basically M1 V1, okay, M1 V1 R1. That's it. Just a moment, guys. And then what do we have over here? M1 V1 R1. M2 V2 R2. My mistake. Really sorry. This is my mistake. Okay. Very important. Okay. And it's 90 degrees. And then similarly for L1 we will be having the same thing. We'll be writing down L1 is equal to M1 V1 sin theta 2 sin theta 1. L1 is going to be M1. I'm writing down M1. That's very simple problems. You do it methodologically, you get a lot of issues. Just a moment, guys. It's a very simple problem. I don't know why are we having that writing mistakes in this case. Okay, M1 B1 R1 sin theta. So there's going to be M1 B1 R1. So no M1, it's just M. It's M. Alright, that's it. We have to equate them and we'll get the answer. End of this story. Okay. Okay then. So we know M V1 R1 is equal to M V2 R2. Cancel out this thing. We are supposed to find out the ratio of the distances between them, isn't it? So between the closest and the farthest. So basically R2 is to R1. R2 is to R1 is how much? V1 is to V2. Okay, and we very well know that given to us in the question. So it says something like this, that V2, that is at the nearest point, is going to be how much? 6 times V1. Okay. So that's it. That's all we need to know. It's a very simple problem. R2 is to R1 is going to be how much? 1 is to. Very simple question as such. Very easy question, huh? Kepler's law-based question. Let's get into the next question then. We have one more question coming up. Okay, so now we have okay, this is a really interesting question. Why would I say that? This is definitely a very good challenge. It involves good amount of concepts. There are two planets, one having mass m, another having 16 m. The radii are a and 2a respectively. Separation between the centers of the planet is 10a. A body of mass m is fired from the surface of the larger planet and it moves towards the smaller planet along the line joining the centers. Now, for the body to be able to reach at the surface of smaller planet, what should be the minimum firing speed of that body? So no guesses, no shortcuts, no one word explanation, etc. It's a very interesting problem, like a very interesting. Okay, so there are two planets like having mass m and 2m, as you can see over here, and they are separated by a distance, how much? 10a. It's a very interesting question. Just focus on question. It's going to be super easy. And from the center, we know the distance to this edge, how much? Center would be somewhere over here, but I just didn't want to draw that like that. Okay, and how much is this? This is 2a. Okay, and from here it's a, and the masses are written. One has mass m and other has not 2m but 16m. Okay, this is written as 2m, but just focus. Now the thing is, what you're doing is, try to understand this question carefully. There are very important two aspects of this question. If you are carefully noticing it. So you have a body over here. Okay. You are projecting this body from here in the straight line joining the centers. What is happening is after a certain point. Okay, first of all, what is happening? It has to go from here to here. Okay, and that would only be possible if after a certain point, initially, let's come this way. Initially, force on this object, due to 16m mass is greater, right, than that of mass m. That means the body would be on the surface of 16m mass, and this is going to be true until that certain optimal point, that certain balancing point where the force is going to be 0. Force due to planets having mass m and 16m would be balanced. Okay, so think about that point where the force due to like 16m planet and m planet is balanced. In that specific case, what is happening? In that case, yes, of course, at that point, like your body can remain in equilibrium, ideally speaking. It may not move anywhere, but beyond any point beyond this, what is going to happen? Your force due to mass m is greater than that of 16m. Then automatically that object or that body that you have projected would reach that place, right? Reach that surface of the planet. We don't need to think so deep about it. We will come to know which is that. That's all. But there are two major principles in this question. First is gravitational field. Okay, the planet, or sorry, in this case it's not planet. In this case, an object has to move from one planet's gravitational field to the other planet's gravitational field. Basically, the gravitational field's influence of one planet should be greater than that of other planet for this to happen. At that point, everything is taken care automatically. Okay, so we need to first of all find out that distance. It's a very simple problem as such. Nothing is there in this problem. It's really a very simple problem. Okay, so let's get into this. So first of all, we need to find that balancing field point or this balancing force point, however you would like to call it. Like this is, it's 2a. Okay. This distance 2a, this distance. Okay, so initially object body was over here. It had some mass. Okay, we know that at some point it's probably going to be a point very near to small m. That's when the force due to small m should be greater than that of capital M, because it has mass 16m, right? 16m by r square is the gravitational field on the surface. Still not that great near that. Okay. Even on the surface, they have 4 times more gravitational field. So let's assume at some distance x, what is happening? You have that point where the field is balanced. First of all, you'll be finding out field or the force on this object due to m and 16m are balanced. Anything beyond that, already it's taken. A little greater than that should be the answer. But anyway, your answer is going to be the optimal point. And then what is this distance going to be? This is going to be like 10a minus, because the distance between both was 10. Okay. Now that comes the thing, we need to find out that x point. We are not worried about anything. We just first of all need to find out that x point, and then we'll get into rest of it. First of all, let's identify what is that x. Okay, we could have said it from the center. It's from the center 10a distance, right? Then let's keep everything from the center then. Okay, just a moment, students. From center is 10a. So let's do a thing. Let's keep this from the center. This is x and 10x, and this cannot be 10a minus x. Keep this from the. Okay. Damn simple, trust me, and there is nothing complicated. X means the other one is going to be from the center 10a minus x. Okay, so take this mass to be something like m. We'll be saying f of m is equal to f of 16m, which gives us g into m, which m? First of all, we are dealing with this m. Okay, so m into small m divided by x square, g into 16m divided by 10a minus x whole square. A pretty simple problem because the calculation is too much in our favor. If you're okay, this gets cancelled out, and g, m, small m, capital M gets cancelled out. And if you take a root on both sides, we'll be getting something like this: 1 by x equal to 16 root, okay, which is going to be 4 divided by 10a minus x. Okay. Okay. What should be it? 4x is equal to 10a minus x. Taking it on the other side, 10a minus x is equal to 4x. Okay, x is equal to 2a. Yes, 5x is equal to 10a, x is equal. Now we know what is the value of x from the center of this planet. We know from this center it is 2a distance. And now comes the next thing. So that means how much distance from here? From this center, take 8. 10 is the total distance. Okay, now comes the really important part of this. Okay, we'll move on to the next page. This is where the most important point lies. What is the next thing that we are going to do to reach up until this point? If you know the body is over here, let me just quickly explain you what is happening. How would you know what is the velocity that you should be giving for it to reach this point? Really simple. Of course, the principle is conservation of energy. But yeah, multiple systems are involved in this. You need to make sure what is the velocity that you will give such that your kinetic energy is going to become 0. Okay, and here it has some definite non-zero kinetic energy. Potential energy will be due to both the planets. Okay, first of all, let's look. This point is going to be really easy to calculate potential energy because we know the distance from the center of the planet. Here, in terms of mathematics, here is the place where we typically, spend some time to find out the potential. Let's just focus on the initial potential energy of this particular object. Okay, so two kinds, due to mass 16m and due to mass m. Okay, so carefully if you are looking at it, and do not mess up the signs, everything will. Okay, so it's going to be due to mass 16m and plus that of mass m. It's on the surface. Okay, what is the radii? Radius 2a. So due to 16m, what it is going to be? Okay, let me write down that 16m thing over here. Going to be on the body having a mass small m. We can say this to be something like minus g 16m divided by into m divided by how much? 2a. Okay, and this is going to be how much? 8. So u of 16m going to be minus 8 gmm by a. First thing we had. Now due to this, how much distance is this from the center of this planet? Basically 10a minus 2a. That's it, right? So This is 2a distance. Let's carefully understand. And both these planets are separated by how much distance? Like something like 10a distance. Means this is going to be 10a minus 2a. So this is going to be 8a. Basically. We have a very interesting equation, but a little interchanged one. But anyway. So um is going to be how much? Minus g into capital M into m divided by 8a. Almost end of the story. Little bit more is there in the story. Add them both or just keep them as it is. Okay, let's just keep them as it is. We'll carry forward and maybe like our final conservation equation, because that is going to be a lot easier. Not now. Okay. Typically you want to do this as well. Now the next thing is, once it has reached that optimal point, which is 2a distance from that like mass body with mass m and radius a. So it has reached this point. Then the body is at a distance 2a from this and 8a from this. What about this body? Mass m. Right. Now, how do we work around this question? Really simple. So, due to this body, we'll write on each and everything again on the left and the right hand side. So, due to mass m, what is the potential energy? It's minus of G into m divided by 2a. Okay. And on this side, what it is? Due to 16m mass. Just due to 16m mass, just think about it, just like how we discussed here. It's 8a distance from the center, so minus g 16m into m divided by 8. So u 16m is going to be how much? So it's basically minus 2gmm by a. Okay. Now we have pretty much all the values we need, and the only thing that we need to understand is conservation of energy between those 2 points. This is where everything lies. It's double concept. Okay? 2 concepts are in. Okay? Carefully for that thing. Other than that, we have nothing in this question. So you have a mass having initial body kinetic energy to be present. We'll come to that point. Okay. So you have this body here, and it has reached this point. Okay. So we need to first of all assess what is the total energy, this initial point, and total energy at the final point. They have to be equal. Some kinetic energy is given in this case, which is like something that we'll take it as half mv square. And let's do a thing. Let's label this as um dash, 16 dash, basically just given a dash. Now other than that, do we need to know something? No. So we know one thing: total energy and kinetic energy at this point is 0. Okay. Total energy, just a moment, let's take up that space. And I'll choose it. So we know total energy initial is equal to total energy. Total energy initial includes some kinetic energy, which is how much? Half mv square. And if you remember, due to the large mass having mass 16 m, how much is this? Like 8 g capital M into small m by a, and due to the other one which was at a distance 8a from the center, right, how much was this? This was something like minus of 8 into g into m divided by, sorry, what, 8 in the denominator, numerator, 8a as g m by 8a. And then what do we have? This is equal to something like the final only potential energy. We finally only have potential energy. And what was the potential energy? This was 2a distance, just reminding you, but rest is things that. And the other one was 8a distance. Always calculating from the center, and we have in fact done the individual as well. Okay. So basically minus 8 minus, due to 16 m mass and m mass we had, due to m mass it was how much? Something like minus gmm by 2a, and on the other side we had something like minus gmm into 2 by 8. Okay. So that is it, end of the story, I guess. We definitely, in such questions, it is definitely necessary that you go back and verify everything. Since I am doing the same thing, okay. Anyway, that's it. I think we have approached the conclusion. That was what I am observing as 8 GMM, and there is 2A on, which is yes. And apart from that, gravitation field where it was square and x, okay, 4 times side 4, take that x on the numerator though, 4x, and a minus x, 4x, and x, we have 5x is equal to 10a, so it should. Okay. Now we get into this calculation. We say half of mv square is equal to something like, you make this positive, so you'll be having, let's take out few things, okay, gmm a, and when this goes on the other side, it's basically 8 minus 1 by 8, sorry, plus 1 by 8, my mistake, because this will also become plus. Then we will have over here minus 1 by 2 and plus minus 2. Okay. Minus 1 by 2, and again, so this is going to be like 6 minus 1 by 2, so that would be like 11 by 2 plus of 1 by 8. 1 by 2 plus of 1 by 8 should be okay, just a moment. Gives you when we have 88 plus 1 2, that does not well 2 divided by Just a moment. If I think the procedure is concerned, everything 6 half 5.5 5.5. It's approximately 32 planets mass m are having a radius a and a. Relation between the centers of the planet is 10a. Okay, between the center is 10a. Okay. And the body of mass m is fired from the surface of the larger planet towards the smaller planet along the line joining the centers and along the line joining. So what is the minimum speed it reaches surface of the smaller planet? Minimum firing. We took this to be x. Force is x square, 10 x. Top will be having 4 because 64, right at 64. We have 4 divided by 10a minus x, 4x. We have this carried on the other side, x 5x. Okay, 2a. Okay, 2a. Yeah, I think this is it. Initially, for which one we calculated for initial 16m, it's mm by a. The one it's going to be 8a distance of its planet minus gm by 8. This is also okay. The kinetic energy will be 0, that is also gm by 2a distance. Okay. I think some approximation is involved in the final. Probably, or are we missing out something? 8a distance. Okay, that means it should be it should have been 540 or something. Just verify this. Overall, okay, minus 8 gmm by a. Okay. 8 gm. Going to be 8 plus 1 by 8. Is that correct? Yeah, that is. What do we have? Minus 1 by 2 minus. I think that is also. And, 2 due to okay 1 by 2, is that correct? Yes. What is going wrong? I think everything is fine. The calculation we have, that is fine. So yes, let's do a thing. Let's take 8 as the common denominator. But 64 minus 16. I think I did calculation mistake, isn't it? Sorry, I think everything is where it has gone wrong. Let's take it up this way. 8 8 is 64. 64 minus 16. So that would be like yeah. Anyway, I think this is where it is. 8 8 are 64. 64 minus like 16. So that's going to be like 48. 48 plus 1. 49. 49 minus 4. 40. This is where it had gone wrong. Okay, that's it. Okay, that's it. That's it. So yeah, conceptually it's all fine. I think last step at we will have v square by 2 is equal to something like gm by a into that of 45 by 8. So this would go off. This would be like 4. And velocity is how much? So 9 5s are. So 5 would remain inside it, and a would remain inside it. A and gm would remain inside that. We'll have something like 3 by 2. Okay, okay, I think little this question. Okay, anyway, let's get into the next question. It was simple. This is again somewhere you're measuring the weight of a box on a spring balance at north pole, and it is then recorded on the same balance if it is shifted to equator. What is going to be the difference? First of all, it has to be less than 196. Okay, so how do you solve this problem? It's a very simple problem, but it involves a lot of calculations. Calculations is something that you should take care of it during the exam. So you have a planet like this. Okay, and this planet of course going to rotate, right? I hope you know this thing. We just discussed the concept today. If we are measuring at the equator, let's say this side, either side it's going to be the same. What is the g effective in this case, or g net? It's going to be basically like total gravitation field minus of omega square capital R. Capital R is the radius of. Okay, given that radius of Earth is R. This thing. Next, so weight is basically going to be something like this. And at this point, when you're measuring, what is that only thing? No centrifugal force effect, etc. So this would just be like mg. What's the center of Earth? Okay. Here, if I'm going to measure weight, it's going to be mg effective. Okay. So first of all, we know mg value is given to us as 196, but we need to find out the value of uh, omega square r to know what is going to be the net weight. How do we find out this thing? First of all, we need to find out omega. R is given to us. What is omega? This was a question in an exam, but I wouldn't have done this question if it was in the exam because it would take a lot of time. I don't have access to calculator. It's going to be, and even the options are not given in that way. But this is the way to go about it, right? So 2 pi by time period. What is time period of rotation of Earth? 24 hours into 60 minutes into 60 seconds. Okay. That's it. You substitute this value, you multiply it with R, which is like 6400 into 10 to the power 3, and you will get the answer. You'll get first of all omega square R. You need to subtract that from 10 and say, like you'll multiply it with the mass. So from this, we know mg is how much given to us as 196 newtons. That means the value of m is how much? They said take g is equal to 10. Means it's 19.6 kgs. You simply multiply this 19.6 kgs with the g effective, you will get same thing is done, and you'll get it approximately to be like 195.33 newtons. Definitely this is something take a lot of time to do that, so hence what do you think? Anyone to do it? Alright, let's get to the next problem then. So there are two spherical bodies of mass m1 and m2 and they are having a radius 1 meter and 2 meter respectively. The gravitational field of the bodies with the radial distance is shown below. The value of m1 and m2 is how much? Very interesting question. Do you have field? Okay, it's two spherical masses having some mass, we don't know what they are, and they have some radius 1 meter and 2 meter. Very simple question. The moment you have a look at it, you know what you need to do from the graph. Okay, let's get into this point. So here is the question. This is happening where? On the surface of the planet. Okay, right, and this is a planet that is having a radius how much? 2 meters, that we know from, and at 1 meter it's going to have maximum. That's it, end of the story. This is also surface of the planet. Okay, let's get into the calculation. What is the calculation that we need to do? We know that let's call this to be like E1. Okay, max. We are just talking about E1 max, or on the surface. How much is this? This is going to be G into some M1. We don't know what is this M1 value of that spherical body. Okay, divided by 1 square radius of that body is equal to how much? Basically something like 2. Very simple. It's all in essence, but anyway, you're just going to take the ratio. So then what do we know? We know m1 should be how much? 2 by g. Simple. And then we do have E2, which is like on the surface of planet 2, having how much? 3 some Newton per kg as its this thing, as is its maximum field on the surface. Okay, and this is going to be how much? G into m2 divided by 2, going to be G m2 by. Okay, then what is the value of m2? M2 is going to be something like 12 divided by okay, then what is the ratio of m1 to m2, students? It's basically going to be like 1 by 6. Yeah, from both of them we can say m1 is to m2 is, we need m1 is to m2. This, and we just say m1 to m2 is equal to 2 by 12. G would get cancelled out. Basically 1 by 6. End of the story. Yeah, you will have used any shortcuts, if any, just calculating it. But this is like a cakewalk question. This has to be definitely done on your because you can certainly get the marks that you. Okay, I think an asteroid is moving towards the Earth directly. What distance of 10 has a speed 12 kilometers per second, neglecting the effect of the Earth's atmosphere. What will? This is a very simple question, isn't it? So what kind of question is this? Basically, I think it's just conservation of energy, and you need to substitute the value of this thing, velocity. Try and do this. Of course, in this case also you'll be seeing a complicated calculation, and try to approximate it. We'll get into this question in the upcoming out of time. definitely have a look into this question. This is a very simple question. It's conservation of energy, and of course you're given escape velocity. Make use of the escape velocity in your given the question. Okay. For potential energy, I think you will be making use of GMIR. In this case, you will be making use of, okay, and MM would always get cancelled out in our case. So like that M of the asteroid, so you're not worried. Okay, then we have many more interesting questions. These are all like very nice questions, conceptually testing. Like few questions. I think 2020 PYQ will be ending it on Tuesday. Suppose that we'll be also 2019 possibly with the next week we'll try and complete rest of the discussion around the gravitation PYQ. The past 10 years, it's going to be very easy. It's like typically you don't get the question like what we second one was also an easy question, but like the third one, I guess third one was really cool. In terms of your calculation, you need to definitely, I don't know how do you do that in exam, but yeah, definitely I think but still conceptually it was very easy. Definitely rest of the questions, most of the questions are very easy. Like the first one, it was just like half a minute question, not even that on the concept. That's it. So that being said, students, this Sunday and Monday at 10 a.m. We'll be having our special class on your Unacademy learning app, which is going to be your PYQ discussion on current and electricity, the most important topic of your JEE mains, right? You typically get 3 questions from this topic alone. We have discussed pretty much of your 2020 JEE mains PYQs of current and electricity in the first session. So try and complete them, and not only that, we'll be discussing few more of 2020 and 2019 questions in the upcoming session. We'll be probably completing all this 10 years discussion in probably with Monday, if not by another extra session. We'll be thorough with your current and electricity PYQ. So try and complete them, and this is going to happen from 10 a.m. to 1 p.m. also on Monday at the same place. That is going to be your Unacademy learning app. It's a free of cost special class, so you can enroll today, one of the most important topics. Okay. And that being said, we have already completed electrical measuring instruments in one shot. That is just in one class. We have completed every concept around your electrical measuring instruments. This includes your galvanometer, coil-based torque problems. We have also completed many more things in this just one session. And that includes also, like voltmeter, how to convert galvanometer to voltmeter, galvanometer to ammeter, and then many more things in this just one session, like meter bridge and correction of meter bridge, potentiometer, how do you apply potentiometer to compare EMFs, to measure EMFs, to measure internal resistance, just in one shot. That is like 4-hour session. We have discussed everything, and it's again a free of cost special class, which is available on your Unacademy learning app. So try and complete them, students. It's available all for free of cost on your Unacademy learning app. The reason you want to do this is it's a very simple topic, and electrical measuring instruments is one of that topic from which you typically get at least one question among your current and electricity. Among those 3, one can be just from your electrical measuring instrument. If not, it can be even more. One, you can say, to a great extent, that you may get or you will get a question from just electrical measuring instrument. On all it requires is 4 hours. We have also discussed different kind of model problems, so it's worth attending it. So try and attend the whole session. And that being said, students, if you are not yet on our Telegram channel, do get on to our Telegram channel. But if you don't have a Telegram app yet, just do download the Telegram app from your Google Play Store and App Store, and post that. Just click on to this link which is available in the description box below, and post that. You'll be getting onto a Telegram channel where you will be getting live before time updates on every session conducted by a JEE English team, be it on Unacademy learning app or be it on Unacademy JEE English channel. You can also type in JEE_English to find us on Telegram. Okay, and also we keep you posted with the latest news and updates on our Telegram channel. And that being said, students, if you don't have an Unacademy learning app yet, just type in Unacademy on your Google Play Store and App Store, and the first search result is going to be Unacademy. Just install this. Why should you have this? Because this is going to be one of the best learning app with a lot of free of content for your JEE Mains and JEE Advanced preparation. We have actually, I have completed many sessions for free of cost, and many of the educators have completed many sessions for free of cost. So like we have many free content, and I keep conducting A to Z sessions, PYQ sessions, one short session, all full length, high quality content for your JEE preparation. So just download it, log in, and follow me to get live updates. Possibly try to complete the old classes as well. And yes, just follow me and you'll get live notifications on every such free class. So do download an Academy Learning app. You will also get to attend many national level quizzes for free of cost. You can attend quizzes on Academy Combat Exam. And that being said, students, if you're looking for a complete package for your JEE Mains and JEE Advanced preparation, it's going to be an Academy subscription any day. Why do we say that? Because we provide daily live interactive classes with the best educators across the nation on a very interactive platform with polls and leaderboards. In fact, we have authors of your books like DC Pandey and DC Gupta sir on our platform. And not only that, you will get access to lots and lots of test series set by the best educators. So they are going to be like high quality papers, and post which you'll be also getting analysis, using which you can improve upon your overall performance. Not only that, you'll also get access to lots of live doubt clearing session, which is one of the most important component of your JEE Mains and JEE Advanced preparation. And not only that, students, moreover, it's going to be a fully structured courses on your Unacademy subscription platform. You don't have to worry about the planning. We take care of the planning. We take it in a very systematic manner. In fact, you will have a dedicated live doubt clearing session after every third session, so that you have conceptual clarity. And we also provide you with lots of quizzes and mega quizzes with each course on an Academy subscription. So it's going to be a complete package for your JEE Mains and JEE Advanced preparation, and that too at an economical price with unlimited access throughout the period. So yes, we do not restrict you by any batches or etc. We provide you unlimited access throughout the period. You can access as many courses as you would like. Okay, and that being said, how do you avail an Academy subscription? Do download an Academy Learning app, else you can do it from the web-based version as well. Then select plus, then select IIT JEE as your goal, and then hit on this get subscription. Okay, do log in before this, and you'll be redirected to the payment page, and you must be knowing which program you should be going for. If not, let's say you are a 2021 aspirant with no plan for drop, so you'll be going for a 6-month program, which is going to cost you only 25,000, near about 25,250. So let's say you are a 2021 aspirant and you have a plan for drop. Okay, or you can be in 11th class. Okay, and you have completed significant amount of this syllabus. So basically, you are a 2022 aspirant. Or you are a 2021 aspirant with a plan for drop. You will be going for a 12-month program where we have also started batches for you as well, and that is going to cost you less than 34,600. And if you are a 2023 aspirant, a 24-month program is for you. So this is typically for 2023 aspirants or even students who are aspiring to crack JEE in 2024. We have started batches for you. So this is going to be like a 2-year program, but if you're starting out right now, it's going to be an amazing journey for you. And how much is that going to cost you? Of course, the most economical one, it's going to be less than 70 rupees a day and 25,000 per year. And coming to Iconic subscription, how much is Iconic subscription going to cost you? Iconic subscription is going to cost you for 6 months. For 6-month subscription is going to cost you anywhere around 34,200. 1-year subscription is going to cost you 58,500, and 2-year subscription is going to cost you 90,000 for 2 years. And for 2 years, that means it's 45,000 per year. So what is this Iconic subscription though? So Iconic subscription is little beyond your plus subscription, where you get access to one-on-one mentoring session with IIT and NIT alumni who are educators on your Unacademy learning platform. So you will be getting to get personal advice from them based on your preparation. Not only that, students, this also means you are going to get personal advice based on their experience. So they have previously gone through this journey and successfully cracked the exam, so they know the ups and downs of this journey, and they will be guiding you with the motivation sessions, strategy sessions for your preparation and for cracking. So make sure you select the right kind of program. It's all at an economical price at this like even for an iconic subscription, if you can avail iconic subscription, it is going to be one of the best things for your JEE preparation. And make sure you apply Murli Live Code, be it you go for 6 months, 12 months or 24 month plus or iconic subscription to get maximum discount. And that being said, students, we have recently introduced something known as combo subscription. So what is this combo subscription? A combo subscription is something where you can get your CBSE board coaching and IIT JEE coaching at an economical price at one place with the best educators across the country. So even in your combo subscription, as I told you, we have different combinations. We have a combination of iconic and plus. So iconic of IIT JEE plus of your CBSE board starting at 4,687, and we do have a full iconic subscription, iconic of IIT JEE and iconic of CBSE board coaching starting at a price of 5,500. And we do also have a plus and plus, that is like plus of your IIT JEE and plus of your CBSE, which can cost you as low as less than 90 rupees a day for 2-year subscription, and it is going to start at 3,037 per month. You can also go for plus of IIT JEE and iconic of CBSE, which is going to cost you 3,900 per month, and we do have some of the best educators for your CBSE preparation as well on our platform. And that being said, students, these are two interesting payment options that I typically recommend to students that are planning to avail subscription. One is pay in parts, and another is no cost EMI. And in these two payment options, you don't have to pay all the fee at once. You can split your payments into multiple parts and and pay it without any hassle of going through paying all the fee at once. And we do also have access to debit card, credit card, UPI, and net banking features on our platform. And what is like this now our team is also present on iconic subscription. You can take your JEE preparation to next level with our personal coaching, IIT JEE workshops, expert guidelines, study planner, test analysis. And we have recently launched even batches for 2022 aspirants. Very recently means I think this is going to just begin. This has just begun day before yesterday. So we have launched a mega batch by vibrant educators for 2022 aspirants. So yes, you can attend them. And so yeah, we do also have another batch by vibrant educators on Unacademy learning platform for 2023 aspirants, advanced micro batch. And this has also recently begun a week before, and we have already 2 batches going on for 2021 aspirants. Many more things are going on. These are just few among them. This is Super JEE and Striker batch, and we have launched Legend batch by Bansal educators. Just started on 12th of January. And you can also enroll to RM, which is for 2022 JEE Mains and Advanced aspirant. And students, we will be having combat next Sunday, and we will be having race in next 2 days. So make sure you attend them scholarship test, and we'll be having AIM Advanced 2021 every Saturday, and we'll be having unique DPPs every Monday to Thursday. And that being said, do not forget to like and share this video, because it's a full-length high-quality content for your JEE Mains and JEE Advanced preparation. And also click on that subscribe button and bell notification to get timely updates. And yes, students, that being said, keep smiling, work hard, and also smart to achieve your success. We will be having another PYQ session in just another 15-20 minutes on your magnetism. We are about to complete your 2020 PYQs on magnetism as well. So you'll be having all kind of full-length explanations on this session as well, and we are also revising the concepts in a way such that you're also preparing well for your JEE Mains 2020. So make sure you attend them and you apply. It's at 7:30 today, and do share this session with your friends as well. Even this session with 2021 aspirants, even 2022 aspirants, you can get started on magnetism. And if you want to attend this is going to be one of the. We have many interesting problems coming up today. And of course, magnetism has a trick of mechanics involved in it. We'll look at the shortcuts if any possible. And do not forget to apply Murli Live Code whenever and wherever necessary. You can unlock many features on your Unacademy learning app as well. Right? And you can avail maximum benefit on your Unacademy Combat, get maximum discount on your subscription purchase, be it combo, plus or iconic subscription. And take care, stay safe, bye bye, see you at 7:30. Work hard.